What's up everybody, welcome back to another video within the Generative AI series, and in this video we'll continue to talk about Realtime API. And it's going to be the best one till now because you'd actually see Realtime API in action. You'd actually appreciate the low latency audio to audio responses. So stick to this video till the very end. It's going to be amazing. Also, if you just landed up to this video, I'd recommend that you go back and watch two previous videos because this video is a continuation of those videos. So I can recap some stuff just for you to gain some context. So the very first video, I'm going to hook it up into the cards. We just talked about what Realtime API is. We talked about the architectural challenges. We talked about if you wanted to build a voice bot previously, like a year back or 6 months back, what were the challenges? For example, I also did a video on OpenAI Assistant and I sort of built a voice bot upon it. I talk a bit more about the challenges I faced and how there were a lot of moving parts which would actually hinder fast responses. So lots of challenges while building a bidirectional voice-to-voice communication, right? And in the next video, we sort of build up our solution in Node.js. We build up, like, set everything up. And we build a basic text conversation bot using Realtime API. We built a basic math tutor, and I just add basic question like, what is 2 plus 2? So we're going to build upon that solution with audio files in this video. And we'll get the audio back from the Realtime API, play it, and boom. That's the agenda, that's the target. So let's get into the code. All right, so I'll also hook up the GitHub link for this repo. If you've been following these videos, you would have that repo, and I'll make all the changes within this repo. So I'm just gonna walk you through this new file I created, and it's separate from index.mjs, which we had previously. This one's called index-audio-files. And this, I also wanted to create this segregation because this here is text-based conversation and this here is audio files conversation. In the upcoming videos, I'll have a separate file which would be microphone-based. So, all right, so before I begin, let me tell you, so we're not going to use microphone in this video. Again, as I told you, we're going to build an incremental solution. So what I did in the previous video, I just used text like what is 2 plus 2, what is 3 plus 5, what is the square root of 4. In this particular video, I created a folder, an audio folder, and I recorded all those messages. For example, not sure if you'll hear this, but let me just play it out for you.
Hi, what's up?
So it just says, hi, what's up? Then I have a second audio which says,
what is 2 plus 2?
What is 2 plus 2? Third video.
What is 3 plus 5?
Not video, audio. What is 3 plus 5?
What is the square root of 4?
What is the square root of 4? So you guys get the idea, right? Okay, bear with me. Let's go back to our index audio files.mjs. All right, I'm going to walk you through line by line. So firstly, we need the module, which is about file system. So this is basically so that I can, target my audio folder right here and fetch the, audio files from here. So we need this particular module for that. .env, you guys know the drill, WebSockets. So the Realtime API is based on WebSockets, and we have to connect to a secure connection using our OpenAI API key. So that's why we need the WS module, which is the WebSockets module. We need a decode audio file, and we need a speaker file. So speaker, it's going to speak the response back, and decode audio would be decoding the audios that we have here because OpenAI API accepts a specific format. So we need to make sure that every audio that we have is converted to that specific format first before we send it out to the WebSocket. All right, so we talked about like how this whole thing, Realtime API, is event driven and how we have different event statuses. So in the previous video, we had text-based statuses, In this video, we have slightly different events, which is like response.audio.delta and response.contentPart.done. So audio delta, we get a streamed audio delta response from the server, which will be collecting within the buffer. I'll explain it into the while. It's a bit wild, but I'll make sure that I run through it smoothly. And then we have the second type of event, which is content part done. Basically, we also get a transcribe response, which is great. So we can display what kind of response we're getting from the server. So that's basically that. When that's done, we just console it out on the terminal. And then we have response type done, which is like, I'm done, you have everything. The server is saying you have everything. All right, so I have an audio counter, which I'll explain in a while what it does. Okay, people, cool stuff coming through. So define the audio format, PCM, which is a format that OpenAI uses, and an empty buffer. So as I told you, we'll be getting a streaming response. So we would need some sort of a container to contain the response while we're like getting each chunk. So that's why we need an audio buffer for that. So here's my buffer. It's like an empty buffer. And I initialize my speaker object, and it has certain variations. So I ran into a few hiccups, and I just altered, the sample rate, bit depth, and channels, and I've found my sweet spot. And I would recommend that you use these settings as well. All right, so utility methods. So before, let me just walk you through the socket initialization. This is something we discussed in the previous video as well, that you actually create a secure socket connection using this URL over here. This is the URL, and this is where you would actually create your secure connection. You would need your OpenAI API key for that. And you'd have to state this particular line over here. We have a certain callback methods like on error when the connection is established, and when you get an incoming message. So I have this particular method done, which is like start conversation and incoming messages. So these are like my two callback methods, which I've initialized at the top. So you see incoming messages over here. We'll be doing a lot of stuff over here, and start conversation over here. And these are more like my utility methods, which I'm going to use to decode the audio and stuff. So the very first method that you see, a float to 16-bit PCM, is more like a specific format that OpenAI accepts the audio response in. So this is basically just an algorithm to convert it into that specific format. So, and base 64 encode audio is just a way where you would actually first, so normally from any format that you sort of fetch the audios from would be in float 32, you would be converting into float to 16-bit, which is like a PCM format. You would sort of, then I'm sort of fetching the chunks and converting into a binary stream. So that's pretty much around it. You really don't know. You really don't have to know everything about this step. You just need to know that we're sort of encoding our audio over here to make sure that the format seems to be aligned within our client side and the server side. So the next set of methods are start conversation, where we actually, so what I'm trying to do here, let me explain the algorithm in general, or the series of steps. So I have like 5 audio files done. So I'm sending them incrementally to the WebSockets. Since I don't have a microphone set up with my code right now, I'll be doing that in the next video. But for now, I'm just testing how it goes. So again, baby steps. So what I'm doing, I'm fetching, so hence the audio counter. I'm basically fetching the very first audio. I send it to the WebSocket. Once I get the response, I increment the audio counter and send the next video. I do it up till like 5 when I have like my audio counter hits 5, and that's where I say that I'm exiting and I close my speaker. So this is what it is about. I'm initializing my audio, I'm decoding my audio, and I'm getting a base64 audio data. And once I have the base64 audio data, I send this event to the client. Now, this here says that conversation item create, and you would actually have to do that. You would actually have to create a particular item, and this specifies what the item is. It's a message, and the content is input audio, and this is basically your input audio, which is a base64 audio data. And then you send out another event telling the server that, hey, you've got the item, now create the response. And that's it. Client event is sent. Once we sort of send out the message, it's going to process it, and it's going to send you back a message. And this message would have an audio chunk. Now, these audio chunks need to be stored somewhere, and that's why we created an audio buffer for that. So we'll be using this here. So I'm going to parse my response. I'm going to check if it's a delta. If it's a delta, I'm going to convert the incoming delta into a base64 audio chunk. I'm going to concat this particular audio chunk within my buffer, and I'm going to ask the speaker to speak it out, right? And once my response is received, the whole response is done, I get no more deltas, and I start another conversation, another iteration of conversation. So it's more like a loop. And this is basically, as I told you, that we also receive transcriptions. So response type content part done is basically a part of it, a part of the events that we receive. And here I just log, my transcript. So yeah, that's it. This is like a mini walkthrough. You guys have the GitHub URL. You can go ahead and check it out. So let's go ahead and run this beast. All right. So again, the very first audio would be like, hey, what's up? And I believe then I ask questions like, what is 2 plus 2? What is 3 plus 5? What is the square root of 4? So let's go ahead and run that. Okay, here we go. Client event sent.
Not much, just here to help out. How about you? 2 plus 2 equals 4. 3 plus 5 equals 8. The square root of 4 is 2.
And that's it. This is what you can expect. So what you just heard is like, my first response was sent out, which was like, hey, what's up? And this is the response that we get. And it would just play smoothly. And then I would send out my second audio, which would say like, what is 2 plus 2? It would tell you 2 plus 2 equals 4. And then I sent out another audio which says, what is 3 plus 5, which is equal to 8. And then I asked, what is the square root of 4? And the square root of 4 is 2. Perfect. And once I hit all my, once I exhaust all my 5 audios, it just exits over here. And this is about it. It's so quick, low latency latency and it actually blows up your mind. The reason you appreciate it even more is when you have already struggled with a similar architecture where you have been trying to achieve this kind of latency, and now you're getting in just like one go, which is awesome. And this means like we are stepping into the next phase of conversational AI and conversational AI agents. And I can't wait to build like super useful applications around this. So let me know what you guys think, and stick to the next video, because in the next video we will be providing our audio through a microphone. So yeah, it would be like a full circle thing where we actually create a conversational bot. It gets our audio, it provides a response, and we can stream our audio through a microphone. So I'll catch you back in the next video. Thank you for watching.